Hello, and welcome to the AI Engineering Podcast, your guide to the fast-moving world of building scalable and maintainable AI systems. Your host is Tobias Macy, and today I'm interviewing Philip Rathle about the application of knowledge graphs in AI retrieval systems, also known as RAG. So, Philip, can you start by introducing yourself?
Yes, great to meet you, Tobias, and good to be here today. I'm CTO of Neo4J, joined the company in 2012 as the first product hire. Have been on the graph journey a long time, was inspired by that after probably close to 20 years of working with data and databases.
And do you remember how you first got involved in the data and machine learning space?
Yeah, so I got involved with data long before I got involved with machine learning. And it was really my first job coming out of school. I was working, doing, a software project, and I would write queries, and then we would go to this DBA who would go and work some incomprehensible magic. And then the query would suddenly run 100 times faster. And I was like, wow, what's going on there? And then my next project, I ended up as a consultant doing data modeling, which got me to realize the power of data and structure and how data is a reflection of all these things happening in the business. And then from there, I ended up apprenticing with this kind of like boutique consultancy that nobody's ever heard of. It's called Tanning Technology, but in the late 90s, early 2000s, they were one of the hot small consultancies that I view as being like the wolf of pulp fiction, except for what we used to call VLDB at the time, very large databases. So cut my teeth there, and have just really fell into data really early and fallen in love with it because of what data is and does for the it's effectively a reflection of the business, and it can amplify, and you've got these great feedback loops with ultimately with machine learning and Gen AI these days.
And recently you published a blog post on the Neo4J site called the GraphRAG Manifesto. And as I alluded to, there's this concept of RAG, or Retrieval Augmented Generation, that's been gaining a lot of attention recently with the growth of generative AI models. And knowledge graphs have been around for many years as well. This is talking about bringing the two together for better overall performance. I'm wondering if you can just start by giving an outline about what GraphRAG is and some of the capabilities that it offers beyond just the vector-based similarity search approach of retrieval augmented generation.
Sure. So, probably everyone here listening is familiar with retrieval augmented generation. This is calling a system. User asks a question, or some agent asks a question, and before sending it to the LLM, you run some sort of query that queries your internal system that has information about that particular domain that the LLM might not have been trained on, or that might involve some richer sort of more detailed question. And vector based RAG is the most kind of the initial and most common technique for doing this. It's really handy. It's easy to build, and vectors are often talked about, or vector databases are often talked about as being external memory. And there are a bunch of ways that I look at GraphRAG. Maybe I'll start by saying, well, if my external memory is functioning in some analogous way to that of the human brain, then how is memory stored and how does the brain operate? Well, you probably want something that operates somewhat like the brain, or at least you can see how that might add value beyond something that has a simpler, more straightforward structure. And so vector-based RAG is kind of an easy way to get, a certain amount of a certain distance up the value chain. But, if you really want to take it to the next level, then using something that is structured like the brain, i.e., structuring your data as a graph, and where your data processing runs in the same way that the processing the brain runs, namely by sending signals through those structural circuits and coming back with an answer, you can see how that has some at least poetic appeal. That's one way to look at it. Obviously, there are more rigorous experiential ways people have come to these conclusions. But at a high level, GraphRAG then is just including a call to a graph database that has a graph of your data, so knowledge graph. So whatever data is the subset of the world model that is being represented in your question, ask it questions, and return that to the LLM, which then can go on its own merry way, give you more accurate answers. It also helps with explainability, and then you can also constrain what you're bringing back through some nice security rules because the data is more structured. So it's kind of a next level from what's possible with vectors, and I see the two as very complementary.
One of the challenges that I've seen come up in the context of this nearest neighbor search, the kind of binary retrieval of vector stores where you either retrieve something or you don't, is that just because something is the nearest conceptual semantic item doesn't necessarily mean that it's actually relevant. Because if you have a very sparse matrix or a very sparse vector space, then you could be near to something, but it's equivalent to saying, well, I'm living in Vermont, and so I'm near to Colorado. Where if I have a full map of the United States, then the nearest thing is actually going to be either New York or New Hampshire. And I'm wondering if you can talk to some of the ways that having that more nuanced structural view of the data represented by the graph can address some of those shortcomings of sparsity in the vector space, or whether that's just an inherent limitation of not having enough data. And maybe it allows you to even just say, this isn't anywhere near, it's too many hops away, and so I'm actually just not going to return anything.
Yeah, this is all true. Just because an answer is the most frequent answer, that may mean that it's the right answer. Oftentimes it does, but it doesn't always mean that. And when the stakes are higher, i.e., when having a more refined or a better answer a higher percentage of the time has business value, then actually looking beyond just frequency can create a lot of value. And so one example to pull in, one kind of graph technique is if I have a body of, let's say, customer support documents, which is a pretty common example and kind of implementation in Gen AI land, and let's say I want to do a vector search against some kind of question a user has, my router's broken, here are some details with a particular answer. You might have hundreds of answers, looking at public knowledge bases, but some of those may involve older versions of the router where like the latest version answers are sparse because it just came out, and it turns out the resolution is different because, hey, as a vendor, the vendor fixed this problem, and the way to address it is totally different. And so in that case, having a structure that you can reach out to that might run a calculation like, what is the case that has the most number of inbound resolved dispositions from a customer service agent, or from other people for that matter in a public knowledge base from other users for this particular model of thing. So getting to a particular model is something that you can do more easily in a graph, so sort of narrowing down and getting more specificity, but then also having access to other algorithms. Like the example I just gave is centrality. PageRank is a good example of centrality. And I'd say more broadly, like if you want to look at an analogy, Google and web search are actually pretty good analogies of this, where back in the day, they were doing surfacing results on the World Wide Web based on text matching. Now, vector indexing is a little bit more sophisticated than just string search, which way they were doing at the time. But the analogy sort of carries through that in order to take the next level, they needed to go and build a knowledge graph, which they had this great blog post called Things Not Strings in 2012 announcing Google's knowledge graph. And the idea was by treating my data as mere strings, I'm missing out on understanding the richness of what those things actually represent. So that's maybe an analogy based way of describing the same thing.
Another interesting aspect of this space of retrieval augmented generation is that a lot of the examples are very naive and simplistic of, oh, you just throw your document at this embedding function, it generates the vector representation, you store that in the database, and then when you go to retrieve something semantically proximate, you get the result back. But many of these vector databases also have capabilities to add additional metadata, apply filtering rules to the retrieval. Another space is the idea of vector indexing in other maybe relational databases, PG Vector being probably the most well known example, where you have proximity to that tabular structure so you can use that for data enrichment. I'm wondering if you can talk to some of the ways that this graph representation differs from those capabilities of either filtering on the retrieval path in a vector store or being able to do relational joins in something like Postgres, where the graph structure itself is inherent to being able to solve a particular problem.
Yeah. So if you looked at the vector only databases or like the vector native databases, the Pinecones and the like, yeah, to your point, they're adding capabilities to add metadata to do filtering. And I think if you extrapolate that over time, like you're gonna in 10 years, if you follow that track, you're gonna end up with, some sort of much richer data model than just vectors. And it might look like a graph, who knows? Yeah, it could look like relational. I guess it's an implementation choice which model to follow. At the simplest level, they are, you know, you could say that the analog in either a graph database or a relational database is like just adding additional attributes that let you, and those filters are effectively like not even one hop out. They're attributes of the particular thing. And in a graph, you're able to do that. You can have properties on nodes and labels on nodes, properties on relationships, types on relationships, directions. However, you can also step out one level, two levels, three levels, and either run computation on that or just do pattern matching as part of your querying. So then the question we asked ourselves when we saw vectors coming out is, okay, how easily could we add vectors to our database, much in the same way that Postgres, to your point, and others have added it. Turns out it wasn't that hard to add basic vector capability. There's lots of good open source stuff out there you can add in. And if you've got a database management system, then this isn't that difficult a thing to add on. And you can do a lot more with a richer data model than with just vectors. So I think if you're doing vector only and it's a good enough use case and that's working, then that's great. Then actually maybe it is the right thing at scale to use a dedicated vector only database that can't do anything else, or maybe can do minimal filtering for whatever economics or other reasons. But if you're doing anything where you want to start going a little bit farther down the rabbit hole of using the richness of the data to your advantage, then that's where actually having a database that supports a richer model other than vectors, be it Postgres or Neo4j, can add a lot of value. What graphs add that relational doesn't, a few things, but I think in this context, schema flexibility is a pretty big one, of being able to take whatever data you want to bring in, or subset of data, bring it in, experiment. Oh, I want more stuff. Okay, well, I'm just going to bring that in. It's much easier with a graph. You can just, ingest different kinds of data and new structures really easily. They just become new kinds of nodes and new kinds of relationships. Whereas with a relational database, there's a schema change and a schema migration if there's already data in it, and it can get pretty onerous, especially in production, to add and change the data you've got.
Another aspect of this concept of filtering or graph traversal is the way that you think about modeling of the data. As I mentioned, a lot of the tutorials are very straightforward of you just feed your document into this embedding model, maybe do some chunk size tuning, or maybe let the model do that for you, and then you pull the data back out. As we discussed, some of these different vector stores are adding more nuanced capabilities around metadata, various attributes that you can attach to those documents. If you're building a knowledge graph, that can be an entire project in and of itself, and data modeling is obviously very important. And I'm curious if you can talk to some of the ways that you need to be thinking about that data modeling approach of how you want to represent the data, what types of relationships you're trying to store and retrieve from as you're building out that AI application, and some of the ways that the data modeling becomes a more first class concern in this GraphRAG approach.
Yes, the really appealing and the great thing and the very powerful thing with vectors is you don't need to think. You can, yeah, you need to think a bit, like what documents and chunk size and things like that. But it's pretty much a an autopilot kind of process. You use your favorite Gen AI framework, and it'll chunk things up, and and you're off to the races. And with graphs, as you point out, you need to think through the model. This has always been like a looked like a pretty big obstacle, and I think in practice can be of, especially if I have unstructured data, how am I going to map that to the graph? And the good news is all these technologies we're talking about actually make it much easier to get data out of a graph. This is a new and pretty fast moving space that I'm really excited about. But let's take the two separate examples. You're either bringing data in from some structured format, and that's usually a relational database, or you're bringing data in from un, unstructured text, or you may have both. Oftentimes in enterprise applications, you have your unstructured text, but then you have your reference table somewhere with what are the keywords, what's the product hierarchy, who are the customers, et cetera. And then you want to tie those things together. In the structured case, it's actually become fairly easy and straightforward to map a graph. There's this technique called tables to labels, where every row in a table, if it's a thing table, turns into a node with a label of that thing. And then the properties, the columns in that table just become properties on that node. And then the primary key becomes a node key. So that's a straight mapping. And there's increasingly good tooling to just sort of bring that stuff across. Neo4J's had some for a while, and it's we're surfacing it in more and more places. Likewise, your join tables or your primary foreign keys become relationships, and so each row becomes a relationship object, and if it's attributed, then you end up with properties on that relationship. The tricky part is unstructured data is, all right, how does this even turn into a graph? And it turns out you can use LLMs for this. And so, back in the day, people did various kinds of NLP techniques. Those are still relevant and useful, but LLMs bring a whole new level of power to the game. Now, what LLMs don't necessarily know is they may not know the terminology in your domain well enough in order to know what to extract. But the good news is you probably have that somewhere. You probably have a table somewhere, like I said, with your terminology and all of your product names and so on. So you can then refer to that as part of your entity extraction. And there are a bunch of companies out there that are taking this on, like as a startup of specializing in entity extraction for particular domain kinds of data, et cetera. Neo4j has been building tooling around it. Others have tooling around it. And if you look at the LangChain, Llama Index, Haystack, they all have, Diffbot is another one, they all have tools for doing this that, again, are a bit rudimentary now, but are just going to keep getting better.
On that topic of entity extraction, entity resolution, as you said, that has long been one of the more complicated aspects of building knowledge graphs and maintaining and evolving them. Layered on top of that is the concept of ontologies and taxonomies, where if you want to be a little more sophisticated, you can have hierarchical relationships of what those different things represent, and being able to do kind of ontological traversals of, this is a man who is a member of a family. He is the father. There's a woman who is a member of the family. She is the mother. And so you can then extrapolate those ontological concepts into parent, and presume from that ontological relationship that there are children. And I'm wondering if you can talk to some of the ways that these LLM entity extraction techniques are able to take advantage of those ontological relationships, and some of the considerations around selecting or building your own ontologies and taxonomies to be able to build into these graphs.
Yeah, I think this ends up being one of the strong arguments for GraphRAG having value is the fact that knowledge naturally shows up in these kinds of hierarchies. I have a chair, and a chair is part of a dining set, and a dining set is part of household furniture. And if you're, I don't know if you're Home Depot or Lowe's or IKEA in the business of selling these things. I guess if you're IKEA, it's really important to get each sub component inside. Here's the leg component inside of the chair, and here are the screws. That knowledge shows up this way, but also a lot of company data shows up this way, like product catalogs show up this way, promotions show up this way. The fact that knowledge organizes itself as a graph ends up meaning that, well, if I want to decode what a particular string means, what is this thing, it's not enough to just be able to decode a string, into another string. I don't know, for language translation or something. I need to actually understand how the thing rolls up into these this conceptual hierarchy, or as you say, like an ontology or a taxonomy. And this, like on the analytic side, it has obvious applications if I'm trying to do aggregations at various levels, that kind of thing. But also people conversationally engage in different, you might ask a question about chairs at one moment and about household items at another moment, or likewise with photos and collections of collections, or whatever it might be. So having a graph of your terminology and of your ontology, and then how that relates to the physical things that you're dealing with, can be really powerful. And actually, that's a pretty common use of GraphRAG.
Now, digging into the technical implementation of a GraphRAG system, can you talk us through the workflow of building the embeddings, figuring out how to associate a given vector or a given vector representation of an entity with an appropriate node in the graph? And then on the retrieval side, what the search function looks like, some of the ways that you augment the nearest neighbor approach with the graph structures, and just some of the foundational infrastructure that's required to be able to support these graph representations co-located with or adjacent to the vector data for that semantic retrieval.
Yeah, there are a few different patterns. So one pattern is I'm going to retrieve my vector first, or my vectors. Let's say I have 100 matches and I'm in this customer support kind of use case. Then I want to post filter the vector results based on some sort of graph query. That graph query could look at an ontology. Like it could say, all right, now these vectors are hanging off of these customers who own this particular device, and I want to narrow it down based on the specific device that they own. Or it could be doing a ranking based on like the page rank slash centrality example I gave earlier of like what's the most referenced document by whatever, by customer service agents, or whatever kinds of inbound relationships you're looking at. So that's one pattern, is bring back your vectors first and then filter based on the graph. It could also be a security related filter. Hey, who's the person asking the question? Do they have rights to see this particular thing? Another pattern is you start with a graph search, and then so let's look for a particular pattern. And where you might do this is things that are really outside the domain of both LLMs and similarity search. Let's take supply chain risk. I met with a customer recently who's doing this. Supply chain risk involves understanding, like doing some basic math across multi levels in the supply chain, rolling that up, and then doing some risk calculation based on that. both the multi-level aspect and the math aspect are not, in the sweet spot, to say the least, of either of those technologies, but they're pretty trivial in a graph. So there you would run your graph query, and then there may or may not be a vector component to that particular query, and then return that to the LLM. Another kind of pattern is something I think of as giving you informed creativity, where, hey, I don't really, I can't really get my entire result in the graph or through a vector. And so I'm going to take, a large part of the graph, maybe like, let's say I have a billion scale graph, and you're going to bring back 1,000 nodes and relationships that are surrounding that particular thing that you're looking at. You can easily turn a graph into natural language. Like you just take the thing nodes, and then the relationship becomes a verb, and there's a thing at the other end. So it's like Philip has, I don't know, a cup, and uh, that that shows up in the graph in a way that can easily be transcribed into English or the language of choice. You can then send that set of sentences to the LLM as context and say, hey, here's the situation. And, that then becomes a background prompt and or context for the prompt. And the user can go at it and ask questions relative to all the data I just dumped in. So that's another use. In that case, your knowledge graph becomes more of an assist.
And in terms of the infrastructure to support a GraphRAG approach of being able to not necessarily co-locate in the same storage layer, but at least co-locate in terms of kind of physical proximity for reducing latency and reducing the number of round trips. I'm wondering what are some of the useful patterns people are using to be able to build their embeddings, build the graph, and be able to use them to interact with each other through the LLM as the mediator.
I guess you have two areas where you have patterns. First, there's the graph creation and ingestion. And oftentimes that's not a one-time thing. Like your graphs are living things. And if it's reflecting some system in the real world, you want to get the changes in. And then on the other side, you have, what's your pattern for actually running GraphRAG? So on the first, the pattern is, using a set of tools which the latest, Gen AI frameworks like, again, LangChain, Llama Index, and so on, uh, often you usually have hooks. Those all have hooks into being able to take unstructured text, bringing it into the graph, calling an LLM. Now, depending on how much of the data you have is in structured form, as I said, you can really improve the quality of your unstructured extraction by having structured data that represents your taxonomy or ontology, and so standard patterns for that. So that's on the construction side, and then on your and the one thing I'll add is, if you don't already have a taxonomy to refer to, and your data is high stakes, and you need like 100% accuracy with some portion of your knowledge graph, oftentimes you don't with your entire knowledge graph, just like you don't with vectors. And so you can get good enough with automated extraction. But in certain cases, I've seen situations where there's a part of the graph that needs to be curated, much like, so you have RLHF, right, which applies to models. Here you have knowledge graph curation with human feedback, where if your model is getting things wrong, then having some tooling, and there's nothing really off the shelf now. So this tends to be things that people build for doing validation of the data in your knowledge graph. And then effectively it becomes a sub-training task for a model agent, which then gets better as you go at extracting your particular data and putting it in the right place. Sometimes you want entity resolution tools as well, including off-the-shelf ones. I'll put in a plug for Sensing, which is one that's lightweight and quite good for uh, company entities and where you have name and address and registration data and people information. That can be helpful. All right, now switch to the what does the stack look like on the GraphRAG side? That typically ends up being some combination of pick your, you know, pick your framework of choice, and then either have an LLM or some technology to generate graph queries from unstructured text. We recently open sourced a technology that does this called NeoConverse that lets you have a conversation with a graph. LLMs are getting better and better at writing Cipher, and which is the de facto query language for graphs used by Neo4j, but many others, and is by the way on track to is 80-90% of the way there towards the GQual standard, which is ISO's new query language standard, and is a sibling to ISO SQL. So you have ISO SQL, you have ISO GQual, one for relational model, one for graphs. We can touch on that if you want to loop back to it. And so there are two basic ways you would query your graph. Again, one is to actually have some kind of translation layer that takes a question and translates it to a graph query. Another one is I can take a particular if I have some bounded variety of the questions that I'm asking. Let's say it's any question is going to fit some template and it's going to be one of 20 kinds of things. In that case, then you can actually pre-create a set of queries and then just do extract your terminology and variables from the question and then map it to the graph query, run the query, and give you back the result. So that's another pretty common way. And then in cases where I have a lot of kinds of questions or a variety in the way I can ask the question, but less of a variety in terms of the number of questions, you can actually do a vector search to find what's the best likely query to match up against the question, which is a pretty cool use of vectors. And then the last thing I'll add on the operational side is you also have this whole thing at the tail end of audit and explainability, security, and so on. And graph visualization can often be really helpful for helping to understand why a particular question was answered in a given way. To the degree that I have a graph query that pulls back information about my world model and sends it to the LLM, which then either takes that as the answer or then further evolves the answer based on that raw data. That tells me a lot about the reason that I got to that particular answer, which is a lot more than you can get out of just taking what an LM says at face value, or even like with a bunch of vector inputs. So visualization of your GraphRAG inputs and outputs can help with that, and it can also help in your development process. I've had users come to me and say, "Hey, just being able to see my vectors." In this case, they had done their vector indexing in Neo4j in the graph. Just by having the ability to like visualize my vectors and how they hang off of documents and how those documents relate to each other and how they relate to the domain can be really helpful in accelerating development. So there are lots of parts of the Gen AI stack that are not standardized, but one, to the degree that GraphRAG is becoming or has become part of the Gen AI stack, there is luckily, like I just through amazing coincidence, ISO just came out with a standard for doing graph querying that is largely a continuation of the Cipher query language. And we're committed, as is basically every graph vendor on the planet, towards providing a smooth transition from Cipher to GQual. So it's the first time in nearly 40 years that ISO decides that a data model is significant enough to base a new standard around. So that's notable and significant, I'd say, in the graph space and for anyone in the database space.
Another interesting outgrowth of the attention that generative AI models has brought in is that they brought vector databases and vector indexes more into the common parlance. Everybody knows what they are at this point, and so they have seen growth even just in the semantic search approach beyond the actual retrieval and generation piece. And I'm wondering how this vector and graph combination is applicable independent of the language model or the generative AI application in a similar context.
Ooh, that's a good one. So let me. So you could look at vectors as being like some continuation along the spectrum that started with string search, you know, exact match, and like leading edge and trailing edge, and contains that sort of thing, to full text, to and now vectors is sort of the next thing. It's like a very fuzzy, conceptually based version of full text, a very grown up version of full text. And it's always been the case, like since my very early days here at Neo4j, that you know you have people needing the same kind of textual based tools around either string search or full text or both, and then using that alongside the graph. And in that case, like I see the pattern where you do it in the graph because you can do both of those things inside of Neo4j. I also see the pattern where, hey, I've got tons of data in Elastic. I don't want to forklift that. And the volumetrics are such that Elastic is dedicated bespoke technology for handling gobs and gobs of text. That's great, but then having the graph alongside it, and then usually the way you'd have some hook, which is like a document ID to link the two. So I think that pattern, I think it's the same pattern, that any case where I have text and I have structure in my documents, which you usually do, even inside of a document, you have structure. A particular chunk exists, might be some text inside of cell B1 of table 3 on page 36 of some document that is part of some collection, that is part of some overall filing. And even structuring that data as a graph, so there's nothing about the domain there, it's just the structure, ends up being useful in certain cases. This was a surprise to me. I wouldn't have imagined this, but we had folks in the community starting to discover this. And so it now has a name. It's called the lexical graph, is the graph of structure. So that that can be used in LLM context. I don't know that that can be used in non-LLM context, but certainly there are all the ways in which you would use full text or string search along with a graph, I think are, those all carry forward in the vector based world.
As far as the overall ecosystem, as you mentioned, there are numerous frameworks that have sprung up around building AI applications. Many of them have built in support for various vector engines. I'm wondering what you're seeing as the current and forward trending support for this broader GraphRAG capability and some of the ways that people are bolting on the graph capabilities to the frameworks that don't yet have that out of the box.
Yeah. So I'd say most of the major frameworks do, and those are rapidly evolving. And we're actually working pretty closely with those framework providers. It's exciting for them and our users and for us. And then if I expand beyond that into different parts of the ecosystem, you definitely want more integrations with all the LLMs. So we've got integrations with Bedrock and Vertex AI and so on. We recently announced integrations with better integrations with the different data providers. So good integrations with, to the degree that data is coming in from more analytic databases like data lakehouses, integrations with BigQuery and Snowflake and Fabric. Something interesting we're doing with our Snowflake integration, which is in early access right now, is being able to actually rip data out of Snowflake inside of Snowflake container services, run a graph algorithm, and then push the results back into a table. So you can do all that within the Snowflake environment without having to move the data around. So I think the next level of integrations is going to be along those kinds of lines to be able to retain your data gravity where and when you want it and run your graph querying using a specialized graph technology alongside all the various things you're doing from data storage and processing to the LLM itself, be it a foundation model or a series of small models.
In your experience of working at Neo4J, working in this space, working with customers, I'm curious if you have seen any broad trends as far as different families of language models or different types of embedding models that lend themselves more effectively to this graph interaction.
I don't. I. It's definitely the case that from one day to the next, like there will be some model that'll come out that'll be better at writing cipher, and yeah, I'd say it's such a game of leapfrog, and it's such a vastly changing landscape. I'd say not really. Probably the only generalization I'd make is the one a lot of your listeners probably have experienced themselves is oftentimes you start with just the largest model possible that'll give you the best results, be it, Claude 3.5 these days or GPT 4.0, et cetera. And then, once you have something working and have demonstrated that it can be done, then oftentimes it can be more economical to break that up and move into smaller models or to use the large models for just a particular part of your workload. I'd say to the degree that you're leaning more on RAG, be it graph or vector, and have the data yourself, then it matters less which model you use. And then the less of a dependency you're able to have on your own data, the more you need to depend on the foundation models and the more there's value in going after a big one.
And in your experience of working in this space, surveying the GraphRAG landscape, working with customers, what are some of the most interesting or innovative or unexpected ways that you've seen these ideas applied?
Let's see. I'll pick on a few. So one is a government tax authority that's doing anti-money laundering and is doing running queries in the graph, but then formatting the results into a suspicious activity report using an LLM. So in that case, it's like your locus of reasoning is in the graph because it involves numbers and multi-hops. But then you're using the model for what it's good at, which is language. Uh, Similar sorts of things in outbound email remarketing of I'm going to come up with the ideal recommendation for this person based on what they've bought and what other people have bought and what they've bought together and what they have in the shopping cart together and so on. That's a very graphy kind of query where you get amazing results in the graph. But then if I want to write an email and I want that email to appeal to a person based on what I know about them, then actually an LLM can do a much better job of coming up with the right language for whoever the person I'm targeting, be they whatever their walk of life is. So that's another, I think, really clever combination of the two different technologies. This one's not surprising in itself, but I'd say the where it's going is maybe surprising. Is there was a recent podcast, the Sequoia podcast training data appearance by the CEO of Klarna, who spoke about how they use Neo4j as part of like a company knowledge base that is a Gen AI kind of agent that anyone can ask a question to, and it'll come back with an answer. And that answer could be related to business process or HR policy or customer or whatever it might be. And so that's not a surprising use, but the surprising thing you said on that podcast is they're beginning to realize that the fragmentation of core data across different systems and different applications like Salesforce and Workday and so on is beginning to hamper their business. And so what they're actually doing is they're leaning into this centralized graph approach, using that as increasingly as the system of record for the core things in their enterprise, and are moving to actually in some fashion like deprecating these applications like Salesforce, Workday, and the rest. Maybe they continue to use them, but they're in a bit more of a targeted read-only fashion, but your system of record is actually this graph which connects to everything. Because there are these incredible network effects with graphs. If you bring together the data to solve, say, a recommendation like I had earlier, that might be 80% of the data you need to do fraud detection. And then together, those might be, 50% of the data that I need for some other use case. And then once I solve that, I solve 3 other use cases without even knowing it. So there are both data network effects and use case network effects. And so I'd say maybe the way I'd characterize the thing about that that's surprising is it's something that started as a Gen AI use case, but then once they began using it, realized that there are applications of graph that go far beyond Gen AI that are quite fundamental to the business and transformative ultimately to their IT infrastructure.
And in your experience of working at Neo4j very closely in the graph data space, and as you're exploring the applications of graph data to generative AI applications, what are some of the most interesting or unexpected or challenging lessons that you've learned in the process?
Okay, so I guess I'd say one is there's this study people often refer to that was done years ago. I think it's by the Air Force is cited. I don't know if it's true or apocryphal, that an error made in the data modeling phase will be like 100 times easier to fix if you catch it then than if you catch it than if you catch it in the build phase after your code's been written, than if you catch it in the test phase, than if you catch it in production. It's like each time you have orders of magnitude more expense in solving a kind of problem that occurred earlier on. So I'd say one is getting your model right. So don't try to get your model too right early on when you're experimenting, but then the higher the more important, the more critical your application is to your business. And I guess you could measure this by proxy by saying, what happens if the system goes down for a minute? Like, is that is that a fire drill kind of moment? Like for those kinds of applications, putting more thought, more attention, more study into how you actually design your application is one. Another is there are some things that are counterintuitive with graphs. So, for example, when you load data, you actually want to create your indexes first before you load your data. This is the opposite of what we do with relational databases. With relational databases, you load your table and then you create your indexes, and then the indexes can take advantage of like a big parallel scan, also, potentially parallel, build your index, and it happens much faster. With a graph, each record that I'm adding needs to actually, if I'm adding a relationship, you are stitching your data together on insert, or you could say like you're indexing your data, or you're pre-joining your data on insert is maybe a way to look at it. And so if you don't have an index, each time I try to add a relationship, I'm going to do a full node scan to find the node at either end, which means by the time you've got a few 100,000 records in, loading each record is going to get really, really slow. You can avoid this by just creating indexes ahead of time. This is a really common mistake. So this is a very down in the weeds lesson learned. I'd say the other lesson learned popping way back out that is maybe relevant in the Gen AI world is I've I've seen so many projects fail over the course of my career because they were purely technology driven and they didn't have enough business sponsorship. Now, I think we as an industry are doing the right thing in this world of Gen AI to be technology driven to a degree, because you have no idea what's possible business wise until you play with the technology. So that seems appropriate. But it's all too easy to then, you know, not look closely at their business or not involve the business at the right point in time as you go and end up with something that's technology driven. And some of the trends I've seen looking beyond individual projects, like the whole trend around Hadoop and data lakes, and no, let's just get all the data into one place, not pre-process it, just dump it in there, and then we can figure out what to do with it. And obviously, like that didn't work very well. So having the appropriate level of business partnership and involvement as one is experimenting with these technologies is, I think, is an art, and where what the right involvement is depends on the situation and where you are in the cycle. But I'd probably err more on the side of involving the business than not. So that's my last lesson learned.
And for people who are intrigued by all of the enhanced capabilities that we've been discussing, what are the situations where you would advocate against GraphRAG, where GraphRAG is just the wrong choice?
I'd say the more something is creative and the less something is high stakes, or the more something is purely based on a document, or the more a language model just has all the information it needs because the data you're talking about isn't your own proprietary data. It's out in the wild. So those factors all, I'd say, lean in favor of, yeah, GraphRag. Maybe there's some way it can add value. It's certainly not low hanging fruit, and maybe it won't add value. Any case where the stakes are higher. So by stakes, I mean, dollar value, but also health and human safety and regulatory and brand and reputation and privacy, discrimination, these sorts of things where if it's a kind of application where these factors come into play, regulation is another, then that starts to tip you over the edge of, I'm going to need to answer to someone, if not a regulator, the person inside the company who is the throat to choke if something goes wrong. And how are you going to convince that person that it's the right answer and that the answer is good enough for enough of the time? Those ends up being cases where GraphRag becomes more valuable. So my rule of thumb personally is stakes. The higher the stakes through any of those dimensions, the more GraphRag ends up being useful. But also it depends on having a question that involves information that is proprietary to your business or whatever endeavor you're trying to carry out.
And looking forward, what are some of the near to medium term, either active improvements in the ecosystem or opportunities for improved support for these graph based systems in the AI application ecosystem that you're keeping an eye on?
So one is development of the frameworks and the integrations, which we talked a bit about. Knowledge graph construction is a huge one, and I'd say text to cipher is a huge one. I think those are the two biggest ones. And those are all areas that are improving almost literally day by day. This is a pretty hot area for us, and I'd say for the larger ecosystem that's connecting in to graphs from the other side.
Are there any other aspects of this concept of GraphRAG, the ecosystem around it, the work that you're doing at Neo4J to help support that that we didn't discuss yet that you'd like to cover before we close out the show?
I think the one thing I'll maybe add is in addition to GraphRag, there are other ways that knowledge graphs are being used and useful. One is around storing your metadata and data lineage of because data ultimately is the foundation. This is partly what I see as the thesis of your podcast, right? Data is the foundation for you know everything going forward, right? I mean, machine learning effectively takes what used to be declarative code and pushes it upstream and makes it a data problem. And so understanding what your data is, what the quality and timeliness is of each source, how data moves across a company, what's been curated, approved by data stored, all these kinds of things end up being very important. And so there's actually a long history, even pre Gen AI, of Neo4j being used as a system of systems of sorts to record how data moves through an enterprise and what the quality is in various places and so on. Some of that is driven from a regulatory perspective, especially in the finance industry, and then some of it is done just for through a more mature understanding by, say, a chief data officer of data is, if not the new rocket fuel, at least the new oil, and there's really something to be gained in investing there. And yeah, so maybe I'll end there. Let me add one more. So this is something that was brought up by some of the framework providers recently, that as agentic architectures get more intricate, they start to look like a graph. And you could actually see a need for a control graph. Now, at small scale and simpler levels, a control graph can just be stored in a file or something. But picture for a global application that needs access to, what's the next series of things I'm going to do in some complex agentic architecture, then actually having a database where you have a control graph that's replicated globally and is the source of truth could become a thing. So I don't know, how important this trend will be or if it's going to go anywhere, but it's come up recently, and I think it's kind of interesting.
Yeah, the idea of using the graph to drive the agent to query the graph is definitely a very interesting kind of chicken and egg problem. It'll be
It's kind of
interesting to
like
see how that all evolves.
yeah, kind of like the Norse snake eating its own tail.
Yes, Ouroboros.
Yeah, yes, exactly.
All right. Well, for anybody who wants to get in touch with you and follow along with the work that you and your team are doing, I'll have you add your preferred contact information to the show notes. And as the final question, I'd like to get your perspective on what you see as being the biggest gap in the tooling or technology or training that's available for AI engineering and AI systems today.
So let me maybe go a little bit more meta on this and say the thing I'd really like to see is more energy spent towards understanding what's going on inside of an LLM. So in a way, like the neurobiology of like how the decisioning is happening. And I'd say, we certainly can advance quite a long ways treating it as a black box as we are, and putting all these controls and understanding the behaviors and coming up with these techniques like RAG and GraphRAG and prompting and fine tuning and so on. But I really want to know what's, the essence of what's happening inside, so that we don't have to treat it as a black box. Because you can just imagine the kinds of improvements you can have if we did understand that better in terms of evolving how models are trained and what a model even is. And heck, I mean, maybe models, I could see models actually even including GraphRAG internally in some sort of fashion. So whatever the outcome is, I think we could gain a lot by turning the attention inwards towards the inside of an LLM, in addition to continuing to spend energy around it.
Yeah, I think that that's definitely an interesting observation, particularly given the growth in recent years of graph being applied in the deep learning context, with PyTorch having graph extensions to that framework, and just the overall idea of graphs being integral to the construction of the neural nets that are used to build these models. And I'll be curious to see how some of those ideas get brought into these large language model and generative AI model development applications.
Can't wait.
All right. Well, thank you again for taking the time today to join me and share your thoughts and experience on this concept of GraphRAG. It's definitely a very interesting problem space. It's definitely exciting to see some of these graph structures and the idea of knowledge graphs being brought into the context of these vector retrieval systems. So I appreciate the time and energy that you're putting into helping to promote that and educate around that. And I hope you enjoy the rest of your day.
Thanks, Tobias. It's been fun.
Thank you for listening, and don't forget to check out our other shows, the Data Engineering Podcast, which covers the latest in modern data management, and Podcast.init, which covers the Python language, its community, and the innovative ways it is being used. You can visit the site at themachinelearningpodcast.com to subscribe to the show, sign up for the mailing list, and read the show notes. And if you've learned something or tried out a project from the show, then tell us about it. Email hosts at themachinelearningpodcast.com with your story. To help other people find the show, please leave a review on Apple Podcasts and tell your friends and coworkers.